Hey everyone, today we're gonna be doing a lead code question which is to find the longest continuous subarray with absolute difference having less than or equals to some limit. So we are given a limit, we can say like we are given some integer array nums and integer limit. So we need to find what is the maximum size. So they are saying return the size of a longest non-empty subarray. Like we need at least one size subarray such that the absolute difference between any two element in this subarray should be less than or equals to limit. So if I say this is some example, we need some subarray from this array which should have the difference as 4. Okay, let's see the constant. They are saying okay, like the length of array can go from 1 to 10 to the power 5, and like the number inside that array can go from 1 to 10 to power 9. Similarly, for limit, it can go for from 0 to 10 to power 5 inclusively all. So we'll see this question like how we can do with some example, and we'll see. We'll take one by one like both the example given in this. So let's take the first example. So I have my example one, which is the okay. So let me write over here. Okay. So I have my array. Just say nums. Nums equals to like 8. It is given okay, 8, 2, 4, and 7. So we have this subarray. We have this array, and we are given some limit. Okay, limit is equals to 4 here, and if you see like output come over here is 2. So let's see like what is this question and what we are trying to achieve over here. So in this question, they are asking us to return the length of a longest subarray having difference of any two number which is less than equals to limit. So if I say very brute force approach, what we can do like we can generate all the subarray. So like as per the last question, or you can say previous question which having this generating subarray concept, the brute force, like very brute force we can do, we can start creating all the subarray. Okay, starting from here, include this, include this, include this. Similarly, starting from here, include this. Okay, similarly for this, include this, and for this only this. Okay, so we can generate all the subarray. So let me generate all of them, and I'll show you the difference of all of them, which is having the limit less than 4. So let me generate. So if I say, okay, I can have one subarray. It will be starting from 8, then 8, 2, then 8, 2, and 4, then 8, 2, 4, and 7. Okay, starting from 8. Now starting from 2, I can have 2, 2, 4, 2, 4, and 7. Starting from 4, I can have 4 and 4, 7. And starting from 7, I can have 7. Now, they are saying absolute difference between any two number. So if I say, okay, I just need the maximum and the minimum from this array, which can give me some limit. You can say give me some difference of like exactly what we need. So if I say, okay, if I take a difference of maximum and the minimum from this array, it will be 0. Okay, but we need at least, you can say, one size sub array. This can't be like answer because this is only one. Or let's say like this is an answer. So the size is 1 alone. Okay, we need the larger size subarray. Okay, so this can be my answer. So let's say, okay, this can be my answer. Fine. This, if I say, okay, 8 minus 2, which is 6. 6 is greater than 4. This cannot be my answer. Okay, this cannot be my answer. Now, if I say, let's take the, if you say like if we take the difference of any two number from here, okay, let's see for this array like 8, 4, and 2. Let's take the difference of this array, which is what, 6. Let's take the difference of 8 and 4, which is 4. Let's take the difference of 2 and 4, which is 2. But if I say, okay, in this particular array, I am having one element 8 minus 2, which is giving me 6 as a result. So I cannot have this subarray having difference less than equals to 4. So I got one thing. If this is my array, taking the maximum and the minimum, having the difference of them can give me my limit value. So I can, like, instead of doing all the differences, I can pick either like just taking the minimum and the maximum from this array, and I can get the what can be my you can say the farthest difference. If I say I'll take the difference of this one, again this one, then I'll take the difference of this. What if the array is long? Like for this one, I'll take the difference of all the element. Again using this element I'll take. Again using this element I'll take. So instead of doing that, I can take my maximum and the minimum number. I can get the difference, because this will be giving me the most, you can say, most biggest result from this array. So if I take the maximum and the minimum and I'll take the difference, it will give me some value which will be the highest value in this particular array. Okay. So using that I can get, okay, here I can get the difference 6, here also difference 6, here also difference 6. So this 3 both cannot be my answer, because 6 is greater than 4, and I need all the subarray having limit less than or equals to k. So this can be my answer, because 8 minus 8 is 0, which is okay, fine. 2 minus 2 also fine. This can be my answer. So this was not my answer. This was not my answer. This can be my answer. This can be my answer, because 4 minus 2, which is 2. 2 is less than equals to 4. Yeah, it is fine. So I can have at least 2 size subarray. Okay, this is 2 size subarray. Let's see this one. 7 minus 2, which is 5. This cannot be my answer again. Okay, 4 can my answer. 7 minus 4 can be my answer. 4 can be my answer. So if I say the maximum size subarray, I can get this, either this or this. But both are of like 2 size. Okay. So I got one approach. Okay. Using this very brute force approach, like generating all the subarray using n square approach, iterate and generate all the subarray. At least I can get what actually we are trying to find. Like we are finding the minimum and the maximum in any such window. Let's say, like, if we are doing this with some two window, you can say two pointer or any sliding window approach, we are trying to find the maximum and the minimum inside that subarray. Okay, if this was one subarray, if this was one subarray, maybe this one was the subarray, this complete can be a subarray, and we are trying to get the minimum and the maximum from that, so we can get the highest difference from here. Okay, so if I take any minimum and the maximum from a sub array, a particular array, I can get the farthest difference which can be achieved. So here 6 can be achieved. So this was not my result. So I just got what, two size sub array which is having limit less than equals to 4. So my output was 2 over here. Now we got, like, okay, we can do, like, by very brute force approach, we can generate and we can iterate over them, which will give me again two, like, n square approach. So how can we optimize it? So if I say we are trying to find the window over here, okay. So what we are trying to find, like, if it is just if this question was just to find whether we have any subarray present or not, what we can do, like, at initial, a very initial, we have been doing, like, okay, we can increase our window size by something. Okay, so let me take the same example. Okay, I might have this array of 4, 8, 4, 2, and 7. Okay, for just checking purpose, do like, can I create any sub array using this limit 4? So what I might have done, like, okay, I have started my some position from here, like, okay, left and right. I might have increase my window size. I might have checked my difference. So whenever the difference is larger, I might have included the element again from the right side. Okay. So for each difference, I might be checking something. But the array is not sorted. What if, like, I include this part, or what if, like, I remove this part? I'm not sure, like, which attribute will be contributing me what answer. So this can be my potential answer, and this too can be my potential answer. But I'm not sure, like, if I do a very basic, you can say, straightforward two pointer approach, or you can say sliding window approach. I'm not very much sure, like, which particular window. So suppose if I have this window, I will have this window, and for each window I might be having my minimum and the maximum. Okay, how I might be increasing or decreasing my window size, because if I say maximum and minimum minus, if we do some difference of maximum minus minimum, sometimes it will be greater than equals to limit, sometime it will be less than limit. So I'm not sure like in what case I can increase or decrease my window. So we can take a help of here a concept of maybe a heap, because we are getting the maximum and minimum from that array. We either we can take heap here, okay, heap data structure. Let's take heap. But if I do this heap data structure, it will take me again n log n time for iterating and searching a specific element in it, or maybe the top element, or like for inserting or deleting the element from the heap. Okay, this can be one approach to get the maximum and minimum. Like we might have created two heaps, okay, main heap and max heap, but it would have take the time complexity of n log n. We'll do a better approach over here. Like we'll say, okay, I have one approach which is a kind of sliding window. Okay, sliding window, but not completely. Okay, so this might be a different thing. Like you might have seen a monotonic stack. So this will be a kind of approach. We will be using a monotonic. Okay, monotonic queue over here, preferably like a DQ. Okay, deck we will be using over here, because we will be iterating and checking for the minimum and the maximum. So let's take the same example again. I have this array. Okay, I have my array 8, 2, 8, 2, 4, and 7. Okay, this is my array. For each case, I might have checking my maximum. Okay, I am just storing my maximum and minimum. Okay, so if I say, if I have this position over here, let's say like I have two pointers, left and right. Okay, I have two pointers, left and right. Whenever I try to increase my window size, I'll just update all those elements inside my maximum and minimum. So currently this this array will have like 8. Let's say like if it is a number, okay, let's say it was not an array, this was an integer, you can say a data, you can say a variable which might only be storing the last known maximum and minimum. So if I say, okay, maximum and minimum so far here is 8 and 8, minimum also 8, maximum also 8. Now what if like I'll try to increase my window size? Now I got maximum as for now 2 is we got some element which is 2, which cannot be a maximum over here, but here it can be minimum. So I can say, okay, minimum I got which can be 2 over here. But if you see like, what if like at some point I might remove this window, I need to check this window. I might be removing my 8. This can be removed from here, but I'm not sure at which point I need to remove. Like after iterating from completely here, then I will be like chopping off and I will be iterating and checking this. So what if like I might take some array, you can say a DQ, okay, where we can push from right and like from both rear and front, I can push the element or remove the element. So I have some DQ, okay, front. So both operations is performed over here. So I have some array, or you can say DQ over here, deck. Okay, so I will be storing my, you can say, the maximum so far here, the last known maximum, similarly the last known minimum. Okay, in the this max queue, you can say max, the max, you can say queue, or you can say deck. We have two decks, minimum and the maximum. Both are monotonic queue or deck. Okay, deck is like doubly ended queue because we need to perform the operation from both the end. Okay, which can be done in the O of 1. So let's say for now, when we have started from here, both my initial pointer, like the right pointer having this 8 as minimum and maximum, we stored it. Okay, no problem. Now I have increased my right pointer to next. I have 2. So for some like to coming next element, I might have some window, might can have some subarray which can have 2 as the maximum element, so I cannot remove or ignore it. So let's say like, okay, we'll take this one for now, and if I say, if I include any of this window, if I have 2 in this window, this will be my minimum element. Okay, so I can remove this directly. So I can say, okay, for now 2 can be minimum in any of the given window. Okay, so I'll say okay, 2 is added in the min def. Now if I iterate again for 4, so if I say now my pointer is at fourth position, fourth data. So okay, I can have my another element which is 4 over here, because 4 also can be part of something. Okay, so 4 can be also my part of something, because this will be some greater element uh, after this. So if I say if this particular element is coming any in any of the window and we are just getting the maximum element, any element coming less than equals to this element in the queue, I can remove this part. Okay, so I can remove 2 from here. Okay, I can remove 2 from here. Now one more thing, like okay, instead of doing this one, okay, instead of doing directly, one more thing we will be checking, like okay, we will be checking, okay, each time when we append the element we will be checking the differences. If at any point if the difference become greater than limit, that means I need to remove my maximum element from here. So I will be removing my this particular the left element. Okay, so I will be removing, like I might be removing this window size currently, so I might be removing this element. Okay, I can remove any of the element. Okay, I can remove this, I can remove this or this. Currently the difference is 0, so I might not be removing. Next time I have added 2 over here, so for this case 2 added 2 over here. Okay, so we have removed 8 because 2 was the smallest element. Now if you see the difference, we can find like the maximum from the front, minimum from the last. Okay, last known minimum we need from the minimum deck, and the maximum we need the first largest element. So I see the difference is 6, that means I have difference 6, that means I need to remove the left part element, the most part element from both the array. Okay, so both the array, that means 8 is already removed from the minimum, we need to remove it from the maximum as well, so I'll remove from here. Now whenever I try to remove, I will be shifting my right pointer and left pointer one bit further, so this will be coming over here. Now if I include my the 4 over here, also 4 over here. Okay, so minimum can be part of here. Okay, this can be part, like okay, next minimum can be 2 if I remove any sub array with 2, which like the 4 can be a part of any other sub window which can be a minimum. For itself it is minimum, for this window it is minimum. Okay, I can have this as a minimum, the next coming minimum. But for this, 2 cannot be maximum at any point of time, so we will be removing this part. Okay, now again we will be checking, okay, this was the maximum, this was the minimum. At any point if this become greater than limit, I will be removing my left part from both the array. For now it is not a left greater than you can say 4, so I will be like in, I will be iterating the next element, I will be adding that. So again if I say if I got 7, if 7 is coming, the maximum can be 7 over here, like at any point if I have 7 in my window, I cannot have any other element less than 7 in my window, so I will be removing this element. Okay, similarly I can add 7 over here, like at any point of time 7 can become a minimum element. For itself it can become a minimum element. So I'll not be removing this. Now if I wanted to get the differences, so I'll take the first element from here, the you can say first element from here and last element from here. So again the difference is 0. So I will be checking the difference of what I have my right pointer, I have my left pointer, which is currently at some position. So I have difference as 5 over here. So I will be shifting again my right and left pointer. So this will be coming again further. At any point, if every time, like while every go, if this was not a case, then each time I will be taking my left minus right pointer plus 1 as a window size. Okay, so if I say okay 0, 1, 2 and 3, okay, so I'll say okay 3 minus 2, which is 1 plus 1, because I need to get the size. So whenever the difference is not greater than limit, I will be storing that as a window size. Okay, so we will be iterating and we will be creating a deck over here. So let me show you with code example how we gonna be doing this. Okay, So I have like let's say like I have created two deck. The minimum deck, okay, minimum deck, which is here DQ, DQ. Similarly, I have my maximum deck. Okay, so I can have maximum and minimum deck, which will be both monotonic. It will be like mono monotonic increasing. Okay, so no, the maximum deck will be in a decreasing order. Okay, so I'll say decreasing. Similarly, I have my this minimum deck. Okay, it will be like monotonically, like increasing. Okay, fine. So now what I need to do, like I need to iterate over the element. So I might be having my left pointer, I might be having my right pointer. Okay. So instead of having my right pointer, I simply can iterate. You can say, okay, I will be having some right pointer, which will be like iterating over the element because at any point, like we will be moving our right pointer one step next. So I'll iterating it from like 0 to size of num. So 1 minus size of 2 num. So it will be iterating from 0 to, you can say, n minus 1 or just size minus 1 you can think of. Okay, so I can have this one. So I have my left pointer. Right pointer is like calculated on the running go. I can have my answer as well. So answer, that means a maximum window size. So I can say max size. Okay, max window size. So I can say, okay, it can be 0 for now. A minimum size can be 0. Let's say minimum size can be 1. Okay, so because at least they say they have said us there can be non-empty subarray. They need non-empty subarray where I if I take any number maximum and minimum itself, it can give me a difference 0. That means at least one size subarray I might have. Okay, so I will be iterating, and for both the subarray, so for both the deck, okay, we will be storing the maximum element in the deck. Okay, so I'll say okay while running at this stack, I need to remove the all the smallest element from the stack. So I'll say okay while deck and the maximum deck. I'll say okay maximum deck the last element. So I need my last element. You can say whatever element present in the deck. I can access using this -1 in the Python for the last element. So I need the last element as the maximum element. Whatever element is minimum, then the right element, you can say the coming element. If any element present in this stack is minimum, then this right element that element I need to remove. So let's say okay, I am removing all the element which is coming. If I say like any element, I'll say the number of this is right array. Okay, if any element coming, you can say any element which is coming to the deck having larger than the last element in the deck. So any number coming is larger than the last element in the deck. That element I will be removing from my max. You can say max deck or max queue. I'll say okay. So I will be doing okay max queue dot pop. That means I need to have only the maximum element. So any number coming greater than the last number, I will be removing that last number from the deck. Similarly, I will be doing it for the minimum deck. So if I say any number which is coming from this array, right? Okay. If this number is less than the number present at the last of deck, okay. So if any number present at the last of deck is smaller or greater, I will be removing that part and I will be placing my right pointer as the minimum from here. So I'll say okay minimum deck dot pop. So I will be removing any number which is greater than the current number. Okay, fine. What I can do, this is minimum, sorry. Okay, minimum deck. Now, every time when this operation done, we need to append this number to the deck. So I'll say, okay, both number deck. I'll say deck minimum deck dot append this current number nums of right pointer. Similarly, I will append this to the maximum deck because every time I am just iterating and removing all the minimum and the maximum from the respective deck, and I will be appending my current number. Okay. Now every time when this done, we need to calculate our max size. Max size will be what? Max size will be maximum of the last max size, and it will be checking the difference of my right minus left pointer plus 1. Okay, so I have this pointer left minus right, and which will be giving me a window size. Okay, so this can be my answer. So let's take it in a single iterator. Okay, so I will be having this as a next coming window size. Now, before this, I need to remove all the element which is like not required. Like, what if like I have some element in the stack, or you can say this queue, which have been not used. Like, if I reduces my window size, like at any point, if I say at any point my this you can say what difference. Okay, so at any point my difference can be like max depth of the first element minus minimum depth. Okay, minimum depth of first element. So at any point if this difference become greater than the limit, that means I need to remove the left element, which is giving me the maximum result for now, from maybe in the maximum deck or the minimum deck. Okay, so I will be removing my left element from both of the decks. So I'll say, okay, if I have my, you can say number of, you can say the left element is, you can say if equals to, like if this element is the front of my max deck. Okay, if this element is the front of my max deck, so I will be removing it from my, you can say max deck. I will be removing it from the front, so I will be doing like left pop. Okay, so I will be removing my left element, so it will like pop left element. That means I need to remove it from my start. Similarly, if this number, okay, so I'll say let's take the both example. So if this number is present in my minimum deck, okay, if this number is present in the start of my minimum deck, that means I need to remove this element from my minimum deck as well. So I'll say okay, pop from minimum deck. Okay, minimum deck. Okay, this will be removing me some any extra access element which is not required for my current window size, which is creating my difference greater than k. And each time after doing this iteration, I will be shifting my left pointer to the next element. So this is what overall code is. So let me compile this code. Let's see if it is running fine or not. We need to return as well. So return our max size. Okay, size. Let me compile this again. So I can see this is running, and let me zoom a bit so you can get what is written completely. So this is what our array is. Code is looking now. So this is what we required completely. So let's submit this code. Let's see whether this is running fine or not. So let it compile and let's see. So this code runs successfully, and this is what we required, and it is bit optimized also. So we are doing this in, you can say order of, you can say time complexity is in order of n, because we are just iterating over the array once. Okay, you can say at max it can iterate at two times, like 2 of n, because our complete element can shift 2 from 0 to right. You can say right can shift from 0 to n, and similarly left can go from 0 to n, like covering, or you can say reducing the window size. Similarly, I can say my space complexity is like order of n, because we are storing that element in the queue. You can say deck or w-ended queue. So yeah, that's all for today's. Thanks for watching.